the scientific method is not like a translator. It's actually a way of doing science. Okay? And what it usually involves is making an observation or posing a question. In today's experiment, we're going to pose the question, well, what happens to the mass of a penny as it gets older? Okay? What happens to these pennies as it gets older? Do you think that the mass of a penny is going to increase as time goes by, or do you think the mass of a penny will decrease as time goes by? So the question is, the observation or the question is, what happens to the mass of a penny with time? Yeah, you should work on pen. When you're in science, beginning students will do pencil just because you have a lot of eraser. But in science, everything's got to be permanent, so it's always a good practice to do it in pen. And if you have a mistake, you make a mistake in your data, it's a simple matter of just drawing one line to illustrate that that's a mistake and then writing under it or closest to it the correct data or information. Okay, so as future scientists in this world, you guys start with good habits, and you will be using those good habits in your future classes. Okay, so the two possible explanations of what happens to a penny with time is the hypothesis. We start off with a hypothesis rather than a theory, because a theory is actually a hypothesis that has been refined through many experiments. A hypothesis is simply an explanation of the question or the observation. So, when you state a hypothesis, there better be a because in there. Okay? Because when you put a because in there, it means that you're trying to explain something. Don't just say that the mass of a penny will decrease with time. Older pennies are going to be heavier in mass than lighter pennies, and stop there. That's not an explanation. That's just a statement of what you to expect. It's got to have a because. Because more grime is going to build up on these pennies, and dirt is going to add to the mass. The mass is going to be heavier for older pennies versus new ones. Maybe oxygen is going to react with the copper, and so older pennies will be around longer. It's going to have more oxygen in the surface. It's going to weigh heavier. Or maybe the mass of the penny is going to decrease with time. If the mass of the penny decreases with time, then you have to have a because. Because it gets worn out. Wear and tear will rub off the copper at the surface, and you have less atoms for older pennies. Okay, so those are types of examples that you guys are going to write in your hypothesis. So take a moment right now, if you haven't done so, and go to experiment 1 and write a hypothesis of what do you think will happen to a mass of a penny with time. What will happen to older pennies? And on page 103 at the very top, there's the hypothesis statement, and I want you to write a complete hypothesis on what happens to the mass of a penny with time or with age. So just take a few moments there and kind of fill that in. Okay, let me just grab your attention for a moment. So the first part of this experiment is to actually verify what happens to the mass of a penny with age. And so what you want to do is create a graph. And you can do the graph in one of two ways. You can have the beginning at which, or the year at which that penny was minted down here, and start with the lowest year on the left and the most recent year on the right, or you can work your way backwards. But remember, if you have it in this arrangement, then if your hypothesis is the mass of a penny increases with age, then you will see a trend line that looks like this. Why does it go up as we go to, sorry, that's backwards. You take that back. In other words, newer pennies will weigh less than older pennies. If we look over time, you can see that this is increasing age. If we're in 2006, and so 1996 will be 10 years ago, 86 will be 20 years ago. So we would see a trend that would go like this. The mass of the penny would increase with age, or decrease. The pennies, the newer pennies would weigh less. So this would be consistent with the hypothesis that pennies, older pennies, weighs more. Okay. On the other hand, if your hypothesis is that pennies decrease with age, then you would see something that looks like this. Over time, the pennies would be lower in mass. So this would be consistent with the hypothesis that older pennies decrease with age. So how do we verify that? We do the experiment. The experiment, of course, will require you to grab a handful of pennies. Oops, that's backwards. Okay, grab a handful of pennies, and there are pennies in the back counter over there. What you want to do is use the balance, and you guys are going to use this for the first time. It'll generally be on, but make sure that it's on, and then there's a weighing boat in each balance. What you want to do is just place the weighing boat on the balance and then tare it. Not tear, but tare, T-A-R-E. Tare simply means to zero the balance. What does that mean? It means that the reading now on the balance is 0.00 grams. Not that the weighing boat is 0 grams, but now you have a reference point. It's got 0 grams in it, and the balance is pretty sensitive. If you talk over it, or if you run your hands through it, it's going to fluctuate, because this thing measures to the closest milligram. And so any wind current or air drift is going to reflect on the mass. What you want to do is, usually these things have covers over them, a glass enclosure, and so you want to keep the glass enclosure over the pennies, and then it's a matter of just taking a tweezer, make sure it's 0, okay? Take a look at what you want to do is take a ruler and measure the diameter of the penny, measure the thickness of a penny, okay, in millimeters, and then take that penny, put it on the scale, and then weigh that penny. And in this particular case, this particular penny is 2.518 grams. Okay, 2.518. So you're reading it to the thousandth of a gram. 2.158 grams. This number will fluctuate. So try and wait until it stabilizes. But if it's stable, then read that number. If it fluctuates too much, then just try and wait till it stays on a certain number for like 3 to 5 seconds. Okay? Once you're done with this, make sure you record the year, the mass, the thickness, It doesn't say the diameter, but just record the diameter as well, and then the condition of this penny. Try not to use your fingers, because if you use your fingers in handling these pennies, the oils in your fingers will actually cause the mass to increase. The scale is that sensitive. So use the forceps, put this penny aside, take your next penny, take measurements as well, and then weigh it. So you're going to do this 10 times. Okay? Work with your partner in doing that. Once you get the mass, as soon as you get the mass in the ear, come up to the board, and we're going to do a graph on the on your results. And then we're going to stop about for 15 minutes, talk about it, and then we're going to move on to part 2. Okay? So let's get started on that. Hopefully this will only take about 30 to 45 minutes. And then when we get the class results up here, I will stop the class and then give you a discussion on for part 2, and then we'll move on.